time. When we're looking at relative atomic mass and isotopes, these are related terms, and we're really focusing in on the definitions of these things here. So that's kind of what we're looking at. Relative atomic mass, the key word here in that term is relative. Okay, all of the masses that are given to us in the periodic table for each element, it's found at the bottom of each square in the periodic table, that tells us what the relative mass is. And they're all measured in comparison to carbon-12. So we'll look at what that means coming forward. Okay. It's really hard to measure these directly, so they're using 1/12 of the carbon-12 atom as one atomic mass unit. We call it 1U. And everything is measured in comparison to that. So we're using that as approximately, can you guys please be quiet? Didn't I just say I was recording and I needed you to be quiet? Didn't I say that? Okay, I need 10 minutes, that's all, okay? All right, sorry for yelling. Okay, we're assuming that that all protons and neutrons have the same mass. We're assuming that electrons have no mass because it's really, really small in comparison to the proton and the neutron. And we're assuming that almost all of the mass that's in an atom is based in the nucleus. And that is kind of an assumption here, okay? It's a pretty safe assumption, but it is an assumption. So everything is measured in relation to that element, carbon-12. Now, why do I keep calling this 12 here? Carbon-12. Well, we'll learn more about that in the rest of the lesson. So let's just review something here for a moment. If you want to find the number of protons for a particular element, let's use the example here of oxygen. If I want to find out how many protons oxygen has, all I need to do is look at the atomic number. So if I'm looking at oxygen, the atomic number, which is written in the top left corner here of our periodic table, is 8. That means that we have 8 protons. Okay. It also means that we have 8 electrons as well in its default state. So I'll write that down too. 8 electrons. Okay, now how do we find the number of neutrons? Well, we need to use the mass number to do that. Now, mass number is where we take the atomic mass. In this case, if we're looking at oxygen again, it's got an 8 up here, and on my periodic table it says 15.999. Okay, so that's my atomic mass down here, and I need to round that off to the nearest whole number. So rounding this one off is pretty straightforward, as we're going to round it off to 16. So if I want to find out how many neutrons it has, I will take this 16, this is the sum of all the neutrons and the protons, minus the 8 number that we got before. So there are likely to be 8 neutrons. So this mass number, the rounded off atomic mass, this tells us the sum of all the protons and the neutrons that are found in that on that molecule, in that element rather.
We have learned that the number of protons plus the number of neutrons is equal to the mass number, which is the atomic mass rounded off to the nearest integer. The question is, why is the atomic mass not the same as the mass number? Why isn't it a whole number? We'll come back to that a little bit later.
Okay, when we are dealing with, I'm going to continue to use oxygen as my example here. Oxygen, we said, has 8 protons, but it doesn't always have 8 neutrons, okay? It's always going to have the same number of protons. It's always going to be 8, but the number of neutrons may vary, and the variation is what creates an isotope. So they have the same number of protons. Isotopes of oxygen all have the same number of protons. They're all going to have 8. Okay, in my example, 8 protons. But the number of neutrons could change. So maybe some of them might have 7 neutrons, or some of them might have 8 neutrons, or some of them might even have 9 neutrons. Okay, those are all considered to be isotopes of oxygen. They have the same chemical properties, okay, but physically they're a little different, and that is something just to note about isotopes. Here's some examples when we're looking at hydrogen. Hydrogen always has 1 proton, always has 1 electron, but sometimes may have different numbers of neutrons, and that's what I'm focusing in on in this column here. Okay, most commonly it has 0 neutrons, but some hydrogen, which we call deuterium, has 1 neutron, and tritium has 2 neutrons. So it has different molar masses depending on which isotope we're dealing with. Now, if we add up, sorry, I was going on to another thought here, but let me talk about the naming first. So I name the isotopes by their mass numbers. So tritium, which we said was the one that was at the bottom there with 2 neutrons, is called hydrogen 3. When we were talking earlier about carbon 12, that means that we have 6 protons and 6 neutrons. Okay, so carbon 12 will have 6 and 6. Carbon 13 would have 6 protons and 7 neutrons. Okay, the sum of those two always has to equal that number, the mass number. So getting back to the question initially, why is the atomic mass not a whole number? Well, it's because when we're looking at the atomic mass in the periodic table, we average that out for all of the proportions of different isotopes that there are. And so when we're looking at oxygen, you can see 15.999, most of the isotopes of oxygen have 8 neutrons, but only a small number would not. Okay, and that gives us why the relative mass of carbon is given to us as 12.01, and it's not exactly 12.